Mouth-watering delights, but they are not just greedy indulgence. In fact, they are backbones of today's session in chemistry. Don't believe me? Then why don't I prove it to you in the studio? Hi, I am Devabrata, your friend, philosopher and guide to all things chemical. Sweet aromas and flavors hold court in today's discussion on compounds containing carbonyl group. We will begin with a general introduction to what these compounds are. We will study the nature of the carbonyl group. We will move on to studying the nomenclature of aldehydes, ketones and carboxylic acids. The icing on our cake will be the special exam tips we give you in Exam Decoded. So what exactly are carbonyl groups? They are functional groups where the carbon atom shares a double bond with oxygen. It follows that any compound that contains this group is called a carbonyl compound. Many of these compounds are used to impart aromas to perfumes. They are also used as flavoring agents in food products. This brings us to the subject of what we saw in the bakery. You see, I have a weakness for apple pie, which contains cinnamon. Did you know that the distinct taste and aroma of cinnamon comes from a carbonyl compound called 3-phenyl-2-propanol? It is commonly referred to as cinnamaldehyde. If you noticed, there was also vanilla ice cream. Yes, even vanilla contains the carbonyl compound 4-hydroxy-3-methoxy-benzaldehyde with a much easier to remember name, vanillin. Thus, the flavor and aroma of both cinnamon and vanilla is due to carbonyl compounds known as cinnamaldehyde and vanillin respectively. Now that I have sweetened you up with that information, let's study a carbonyl compound that is very different in both nature and function. You must be very familiar with such sites by now. Biological specimens that have been protected from decay by a liquid substance known as formalin. Formalin reacts at a cellular level with living tissue and prevents its breakdown. Without it, tissues break and the specimen decays. Time now to study the structure of these fascinating groups of compounds. But first, you need to understand a few concepts. The first is hybrid orbitals. Orbitals which are formed by intermixing atomic orbitals are called hybrid orbitals. For example, orbitals formed by mixing an s orbital with two p orbitals are called sp2 hybrid orbitals. The second important idea to understand is sigma and pi bonds. Sigma bonds are bonds formed by a head-on overlap of atomic orbitals, while pi bonds are formed by sidewise overlap of atomic orbitals. Coming back to carbonyl compounds, as I mentioned before, these groups contain carbon which is double bonded with oxygen. This carbonyl carbon is sp2 hybridized. This means it has 3 sp2 hybrid orbitals and 1 unhybridized p orbital. It uses sp2 hybrid orbitals to form 3 sigma bonds which lie at an angle of 120 degrees. The unhybridized p orbital of carbonyl carbon overlaps with the p orbital of oxygen to form a pi bond. We have already studied what a distinct structure carbonyl compounds have. Let's learn a bit more about it. If we study its molecular structure, we observe that the oxygen in the carbonyl group is more electronegative than carbon. Therefore, it tends to attract the electron cloud towards itself. A partial negative charge develops on oxygen and a partial positive charge develops on carbon, thereby leading to the distinctive polarity of the carbonyl group. This makes the carbonyl carbon electrophilic and the carbonyl oxygen a nucleophilic center. Now, as you may recall, nucleophiles are species that attack positive center of an atom in other molecule, while electrophiles are species that attack negative center of an atom in other molecule. Now that we are clear about the structure of carbonyl compounds, let's study some of its types. Aldehydes and ketones are the simplest carbonyl compounds. They both contain the same carbon-oxygen double bond, but there is a difference. The difference is the presence of a hydrogen atom attached to the carbonyl group in aldehydes. Ketones, on the other hand, don't have hydrogen. In aldehydes, the carbonyl group has a hydrogen atom attached to it together with either a second hydrogen atom or more commonly an alkyl or aryl group. You can see the general formula on your screens right now. Take a look at the general formula for ketones, where the carbonyl group has two hydrocarbon groups attached. These can be either alkyl or aryl groups. With that, you have been introduced to the simplest carbonyl compounds. But there is a lot more ahead. So why don't we take a short break? Meanwhile, try answering this. Name an aldehyde which is used in the silvering of mirrors. See you on the other side of the break with the answer.